In this video, we are going to consider three coplanar forces in equilibrium. We will know the conditions for the equilibrium of three coplanar forces. We will also look at how we can use triangle of forces to solve problems involving equilibrium. So we will consider an example where the triangle of forces will form a right angle triangle. Then we'll also consider another example where the triangle of forces will not be a right angle triangle, where we can use the cosine rule to solve for the missing force, the magnitude of the missing force. So let's begin. So you recall that if an object is in equilibrium, then all the forces acting on it are balanced and they cancel each other out. That means there's no net force on an object that is in equilibrium, so it will not be accelerating. If only two forces are acting on the object, as we can see, then it means the forces must be equal and opposite. So for instance, W here must be equal to 4.2 newtons. And we can see that they are opposite to each other. Then F here must also be equal to 5 newtons. If this particle is in equilibrium, the forces acting on it must cancel each other out, must be balanced. What if the particle in equilibrium has three forces acting on it, as we can see? In this case, when we draw the forces tip to tail according to scale, it will form a closed loop, as you can see here. And this is what we call triangle of forces. So one way we can solve three coplanar forces in equilibrium is using triangles of forces. We could also use Lami's theorem, but we will consider that in a different video. Now let's take an example of a question that involves using triangle of forces to solve it. The diagram shows all the forces acting on a particle. Given that the particle is in equilibrium, find the magnitude of the missing force. So we are going to draw these forces tip to tail. Now let's do that, and that will form a triangle for us. So this is the P, you can see it here. Then we place the tail of this force at the tip of this. That's what you can see here. Then we complete it with this, placing the tail of this at the tip of this. That is what we see here. So we can see that all the forces are following one another, and that will give the resultant to be equal to 0, which means the particle is in equilibrium. Now, how do we calculate for the magnitude of the missing force P? Since the triangle here is acute right angle triangle, we can use the cosine ratio to find the missing force. So for instance, we know that cosine of 45 degrees, 45.0 degrees will be equal to adjacent, which is 20.0 over hypotenuse, which is P. So P will be equal to 20.0 over cos 45.0 degrees, and this will be equal to 28.2842. Then to three significant figures, we are going to get the missing force to be to 28.3 newtons. Now let's consider the case where the triangle is not a right angle triangle. So in this case, we have force R, P, Q. And we see that the angle between them, none of them is a right angle. So how do we solve this? We can also draw triangle of forces, as you can see in the diagram. Then, to find the missing values, let's say the angle between the forces, the acute angle between the forces, or the magnitude of the forces. So in this case, we can see the force moving like this is P, and the force moving like this one is R, and the one moving like this is Q. So we see P, then we see R here. So we can use the cosine rule to solve the missing values. So P squared, so this is P, this is R, and this is Q. So P squared will be equal to Q squared plus R squared minus 2QR cos alpha. Then Q squared will be equal to P squared plus R squared minus 2PR cos beta. Then R squared will be equal to P squared plus Q squared minus 2PQ cos lambda. Let's take an example and see. We have three forces F1, F2, and F3 being in equilibrium. The magnitude of F1 is 10 newtons and that of F2 is 20 newtons. If the angle between F1 and F2 is 150 degrees, calculate the magnitude of F3. So let's draw a diagram for this. So we can see the F1 force, which is 10 newtons. Then we can see F2, which is 20 newtons. So the angle between the forces F1 and F2 is 150. So when you extend the force F2, you can see it, and this is F1. And the angle between them is 150. So that means the acute angle here will be 30 degrees. So using this acute angle, then we can now find F3. So F3 squared will be equal to F1 squared plus F2 squared minus 2F1 times F2 cos 30 degrees. So F3 squared will be equal to 10 squared plus 20 squared minus 2 times 10 times 20 cos 30. And cos 30 is cos 30 will be 0.866. 0.866. So this will give us 100 plus 400 minus 346.4. 346.40. So F3 squared will be equal to 153.6. So finding the square root of that will give us the magnitude of F3 to be square root of 153.6, and that will give us 12.4 newtons.